All right, so this is day 9 of our notes. We are actually going to start with a video because the very first video we watched at the beginning of the unit talked about compound interest. Remember that day where I had you vote a penny a day for a month or $1,000,000? That was all about compound interest. And today's starting video is actually from a bank who's trying to inform its clients on what is compound interest all about. Raise your hand if you're in a business class right now. Any business electives? So we'll see if some of the language that's used here is familiar to you. Either way, this idea, you'll see actually an exponential graph as it's connected to money. So let's watch our video to start class to learn a little bit more from TD Bank about what compound interest is before we actually practice using the formula.
With a little bit of interest and a lot of time, compound interest can work miracles. In fact, compound interest may be considered one of the most powerful concepts in finance. Compound interest is reinvesting earned interest back into the principal of an investment. Earning interest on top of interest increases the principal, resulting in exponential growth over time. Exponential growth is the acceleration of growth in an investment's principal. Exponential growth is the result of letting interest compound over time. This idea can be a little abstract, so let's look at a hypothetical scenario to better understand the power of compound interest. Suppose there are two investors who have a starting balance of $10,000 each. They both decide to buy the exact same investment on the same date, and they both plan to hold their investments for 30 years. But one investor plans to withdraw the interest at the end of each year, while the other plans to reinvest the interest and let it compound. Let's fast forward 30 years to see the difference in potential returns. In this example, let's suppose that the investment earned 5% per year. The investor withdrawing interest every year would have earned $500 per year. Over 30 years, the earnings would have totaled $15,000. That's not too shabby. But let's see how much of a difference reinvesting the interest could have made. The investor who reinvested the interest would have possibly earned $33,219. This is more than double the return of the other investor. This is the power of compound interest. Now, let's take it to another level and discuss the importance of time. Compounding over a long period of time can potentially lead to exponential growth of a portfolio. Let's look at another example to understand how important time is to compounding. Suppose two investors have portfolios worth $100,000 each. The portfolios hold similar investments. They both use compounding to grow their portfolios 6% per year. One investor needs the money to retire in 20 years. The other will need the money to retire in 40 years. Let's see what a difference 20 years can make. At the end of 20 years, the $100,000 principal would have grown to $320,713. Now let's see how much the other investor would have earned. As you can see, the additional 20 years of compounding resulted in the principal growing to $1,028,571. That's more than 3 times the return of the other investor. Now that you understand how time impacts growth, let's discuss 3 ways how you can harness the power of compounding. The first step, and perhaps one of the most important, is to start investing early. The earlier you start, the sooner you can gain the advantage of time. The next step is reinvesting earnings. When it comes to investing, earnings are typically in the form of capital gains and dividends. Some brokers may allow you to automatically reinvest earnings, or you can simply buy more investments with earnings from capital gains and dividends. The final step is to avoid possibly the biggest obstacle many investors face, which is taking excessive risks that can lead to large losses. After all, compounding only works if you're earning on your investments. Of course, always earning a profit is easier said than done, because investments sometimes make money and other times lose money, particularly stock investments. You can't guarantee your investments will make money every year, but you can avoid taking excessive risks that can lead to large losses. Large losses can potentially be reduced by allocating your portfolio across different asset classes, such as stocks, bonds, commodities, and currencies, and diversifying your portfolio within each asset class. To help reduce large losses, resist the temptation of taking excessive risks in the hopes of earning fast money. Because when it comes to harnessing the power of compound interest, Slow and steady is a better approach.
So that was straight from the bank to adults who really have no familiarity sometimes with what is interest, let alone compound interest, all about. There is definitely some business language in there that we're not necessarily going to talk about, but for those of you who are in business electives, did you recognize some of those words? Awesome. So this idea of compound interest is the fundamental building block of how banks and savings accounts work. Let's dig into it. To start, we're actually going to do a little bit of an exercise here, this type 1. It says, this is the formula we're going to work with today, so look at where the arrow is pointing. We're going to take an action of letting n equal 1 and see what's going to happen. As crazy as that formula looks, by the end of today, I promise you'll be comfortable with it, because in a second, you'll see how much of this you really already know, even though it looks different. So if we let n equal 1, let's see what happens. Let n equal 1. So we're saying a of t equals, did anything happen with p? No, so that stays. Remember, what I write, you write. Follow me. What's inside parentheses? 1 plus r divided by 1 raised to the, what's getting plugged in for this n? Yep, 1, good job, 1 t. So with your highlighter, if you want to highlight what we just substituted in, we substituted in 1 for n right there and 1 for n right there. Let's see how that's going to simplify. We have p, and then what's on the inside? 1 plus r raised to the t, because 1 times t is just t. So we have a of t equals, let's put this in a box. Does this look like something we've already been working with? Yeah. What does this look like? Remember, growth. What was our formula for growth? F of x equals, good. A. Look how similar that is. So really, the only new piece of this is what variable? Well, p, but p is like what? P and a are the same. N. N is the new piece we're going to tackle today, and it's going to be good, because this is very much a calculator exercise more than anything else. Before we start using it, let's see what our pieces are. A of t is connected to f of x. With exponential growth and decay, what did f of x represent? It does represent y, which represented what in the real world situation? A total of some kind, right? It was like total people, total mice, total of some kind. But compound interest is only about money. So we're going to be a little more specific and define this as current amount. And by that, we strictly mean money. We just talked about how P is connected to what that we already know how to do. What variable is P connected to? A, and A is initial value. In the finance world, initial value is known as principal. That's why it's a P, not an A. P for principal, which does mean initial value. So in parentheses, or like draw a little arrow, that does mean initial value. Has anybody heard of principal as a money reference before? Yeah. Okay. What's R? What was R in growth? Our growth rate, but specific to money, it's going to be our annual interest rate. Now that is a decimal, but just like before, guess what form we need to have it in? We're going to be given a percent. We need decimal form. Remember that. Now n is the new piece, and I'm going to write it in red so it stands out, and I'm going to highlight it. N is the number of times the interest is compounded each year. The number of times the interest is compounded each year. Let's talk about what we mean by that. So somebody has an investment in the bank. If it's compounded annually, how many times is that in a year? Once. So at the end of the year, you say, this is what I have in the bank, I earn this % of interest. For that to benefit you, what did the bank say you should do with that interest? Should you withdraw it, or what should you do with it? Put it back in so it can build up. Up here, let's write a little note. When n equals 1, did anything change about the formula? No. No. Nothing changed. What happens when n is something else? When n equals 1, we just showed ourselves, nothing changes. We're right back to the exponential growth we know. What happens when n is something else? How else is time measured in a year? Days. How many days in a year? 365. So if we're compounding daily, that's 365. How else? Months. So I'm hearing months, weeks. See if you can figure out mathematically what numbers you're going to fill in the blanks. How many weeks in a year? 62. Think. I'm going to leave it I'm going to leave this slide here for a second. You fill in the bottom, and we'll see if we match in a second. Wait. Okay, wait. Am I good to scroll down? Okay. Any ideas? 52 weeks. 52 weeks in a year. Good. What else do we know? Annually is once. Yeah. How about these other ones? Careful. Quarterly. How many quarters in a dollar? 4. How many quarters in 1 year? 4. What else do we know? Monthly is 12. Semi-annually cuts the year in half, so it's 2. Very good. Half of a year means there's 2 halves in a year, so semi-annually is twice. So T, we just left out T. T is always going to be time, and what's nice about this is it'll always be given in years. So these are our possible values of n that you have to know. So if the real world situation says compounded quarterly, you have to know that n is going to be 4. If it says compounded daily, you have to know that that means 365. Very good. So that means that instead of annually, if I'm compounding quarterly, how many times is the bank going to calculate your interest and put it possibly back into your account? 4 times. That's where this financial element comes into play about what's a good choice for your investments. The best way to learn this is to practice it. So let's look at our first situation here. You just graduated and got a sizable amount of money for making it all 4 years. Congrats. Instead of spending it on McDonald's or on sneakers, you have decided to open a savings account. I know, very smart. Good job. You deposit the $2,000 into an account that earns 1.75% annually for interest. So notice you're given an annual rate always. How much money will you have in 10 years if the bank compounds the money, and what three options are presented here? So we're going to do this 3 times, right? So can you remind me, what was typically our first step in a real world situation? Defining our variables. Now with compound interest, I'm not as interested in that, because T will always be time in years, and A of T will always be the current amount of money. So for the notes, I'm only going to do it once. T, time in years, A of T, amount, current amount. Now on a quiz or a test, I do expect you to define the variables each time, but for the notes, I'm just doing it this once. Are we clear on why? What is T always going to be for compound interest? Time in years, and A of T will always be current amount. In our growth and decay examples, it's not as straightforward, right? Because it could be about cars, it could be about people, it could be about termites, right? Much more variety. What were the 2 variables we looked to define first last time? A and R. Now we have 3 to talk about. Instead of A, we use what variable? P for principal. Then R. What's the new one we have to look for? N.
Oh, so there's 3?
Yes. Instead of 2. But do you see how it's really not different than what we were doing before? What's our principal here? How much are you putting in the bank? $2,000. What's R?
1.5.
Careful.
1.75.
1.75%. And are we okay with it as a rate? We need, I'm sorry, are we okay with it as a percent?
No, you have to turn it into a decimal.
How do we do that? You could either divide by 100 or
Move the decimal to the left.
so as a decimal, what is this?
0.01.
Good. What's N? Annually means 1. Notice, we've not mentioned the 10 years at all, right? That's for the follow-up question. So again, here I'm going to model that we are actually going to build our model first, then go use it. So for right now, put the knowledge that we're going to look at 10 years, that's for later. We're going to practice every time writing the model. So if you want to flip to the front, do that. A of T equals what? What's the general model? P times 1 plus R divided by N raised to the N T. Don't drop this N. If you drop that, the whole thing's going to come out wrong. So that's why we're going to write it every single time so we get good at it. Now we're going to fill in what we've got. What do we have that we can fill in?
P.
Which is that? 2,000.
You can put an R, which is 0.01.
Good job. We can fill in the R, which is 0.0175.
You can put an N, which is 1.
Yep. N is 1. And what does this become up here?
1.
1 T. We're going to use a calculator to figure out this if you need to. I mean, this dividing by 1, does that change that decimal at all? No. So for this one, I know A of T is going to equal 2,000 times 1.0175. I didn't technically need a calculator for that, but if you needed to, go ahead. 1 T is just T. Put it in a box. We have our model, now we can use it. What are we looking to find out? How much money will you have in how many years? 10 years. That is going to be for T. Now we have something we're going to use for T. So A of 10. We're going to do each piece. Quarterly's next. So A of 10 will be 2,000 times 1.0175 raised to the 10th. With a calculator, you'll be done in one step. Let me know what you get. Yes, caret and then the 10. Let me know what you get. Because the question was, why is this raised to the 10? Because we're asked, how much money will you have in 10 years? Because your job, the question is, why did I not put 10 over here? What's in green is my work on how I built the model. You need to show me getting the model first, then go use it. Should be two separate pieces of work. Good question. I'm hearing as an answer 2,378.88. Who agrees with that? Who got that? Good. So we've done annually. Let's talk quarterly. What's P still equal? The question was, is this adding a step just to make it more difficult? No, it's a different type of interest. This is purely a financial application. The finance world revolves around this concept. Others as well, but compound interest in any business course is a cornerstone component of how the business world and money works. With financing, credit cards, car loans, all of that. This is a key step. So this is more of a finance equation than a math equation. Math is used for it. So let's talk the quarterly piece here. P still equals 2,000. R still equals 0.0175. Good. But now, what's N? 4. Let's see how this changes things. So we're still going to write our general model first, which is what? A of T equals P. Yes, keep going. 1 plus R divided by N raised to the NT. The more you write it, the better you'll be at it. You'll just know it. So write it every time. Let's see what happens here. Help me fill this out. 2,000. Careful, don't skip this. I saw this happen with growth and decay. Don't forget this 1. If you do, nothing's going to come out right. In this case, 1 plus, way back, if we were doing decay, this would be 1 minus. Okay, just making sure we're on the same page. But with compound interest, it's always 1 plus, because you're increasing your money. You're not decreasing your money. So 1 plus divided by 4, good, raised to the 4t. Because originally, the question was, where's 4t coming from? In my model, it's nt. So if n is now 4, this becomes 4t. In your calculators, please do 1 plus 0.0175 divided by 4. What do we get? Good job. Do we agree with her? Yeah. That's our model. And as crazy as this looks, we are going to let the calculator do all of the heavy lifting. We have our model. Let's go use it. What's the time we're still looking at right now for T? 10. So let's do A of 10. So A of 10 will be 2,000 times 1.004375. What's going to be up here? 4 times 10. So either mentally know that's 40 or like make a little note that that's going to be 40 as an exponent. Use your calculators. In one step, we'll have our real world answer for this. Let me know what you get. $2,381.583. So for money, we'll round that to 58 cents. Confirm that answer, please, in your calculators. If anybody's getting something different, show me, and I'll check how you put it in your calculator. Are we seeing a pattern in how we approach this? Define our variables. What's nice is if you see the word compound, you know you're going to be in compound interest world, right? T is always time in years. A of T, amount and money for our variables. What three letters are we going to define on the left? P, R, and N. What are you going to do first here? What are we calling this? What is this? Building your model first, then go use it. Get your variables, build your model, go use it. So on your own, work on part C. Check in with your neighbors as you're working. Let me know if we match. We matched. I got 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, but what does 12t become? 12 times 10 will be 120 as the exponent. Yes.
Instead of writing it off to the side, could you just I know it's your model and then your equation, but you need the model.
That's fine, yes. So I have to write off to the side just because I don't have space because of the chunkiness of the smartboard markers. If you can very neatly fit the model in like half of the space and then your work underneath, that's perfectly fine. I just can't because of the markers. Yes, we substituted in 10, and that's how we got this answer. come show me what you plugged in. So I roughly cut a head count of half of us. Can I get a show of hands of who is all set with part C? That's almost every single person. If somebody's not raising their hand, just check in with them, please, and see if they're okay. Let's look at the follow-up question. Read part D. So I think the difference is you went one more decimal place here. How did that happen? 0.00145. I'm going to try this again. 2,000 times. Oh, I know. I think you missed the 1. So watch, 2,000. I can't get it to recall it again. 1.001458. Yeah, I don't think you had that. I think you just had 0.00. It's 1.00. And now let's see what happens when you raise that to the 120. Yes.
I didn't get that because I stuck at the slide.
So good question. For accuracy's sake, the more decimal points we have, decimals that we have at the end, we're good. So I would like us to go to 4 after if you have zeros like this, I would like 4 decimals. 4 numbers past. 4 decimals didn't make sense. After the decimal place, if you have these zeros, don't let those count in your head. I mean, they count as placeholders, but I want 4 numbers.
So 4 after those 2 zeros.
Yes. Now, D says, if the interest rate doubled to 3.5%, would the amount of money also double if it was compounded quarterly? That's a valid question. Like, if we double interest, do we get double money? Who thinks yes? Who thinks no? Okay, let's see. So what do we know? What is P still equal? We haven't changed that. That's still 2,000, but what are we changing? We're changing R to what? 3.5%. As a decimal, what is that? And what are we saying for N? All right, figure it out. Go for it. Write your general model, build it, then use it. The more you write this model, the faster you will be at it. Let me know what you get for the number on the inside. Our B value is going to be what? 1.00875. Good job. 1.00875. Do our models match?
Yes.
Great. Now what are you going to substitute in for T? 10. Yep. Yes, 4 times 10 will become 40. Let me know what you get as an answer. I heard $2,833.81. Do you guys match with her? So let's go back and see what the question was. We doubled the interest rate. Did this double the amount of money?
From quarterly?
Yes. Go look at quarterly. Quarterly was 2,300.
No.
This is.
It raised a little bit, but it didn't double.
Yeah, we definitely made more. Like roughly how much more?
Like 5.
Yeah. So approximately 500 more, but not double. That's still a good amount of money more. But this is showing us that just because we double the interest rate doesn't necessarily mean you double your money. You increase it, definitely, but not a full double.
Those are correct decimal. Should we continue?
In terms of our final answer?
Yeah.
The question was, do we keep going with the values here? For our finance world, we're going to round to 2 decimal places for money. Okay. Very good. Let's look at our next one. This is officially a you do. Good question. For this, the question was, do you need to write a sentence? For compound interest, I'm good as long as you give me a label. It's always going to be money. You do. You decide to invest $8,000 for 6 years, and you have a choice. We have a choice between 2 accounts. The first pays 7% per year, compounded semi-annually. The second pays 6.85% per year, compounded monthly. Which will be better? As soon as you see these words, you have a choice or you're comparing to, I want you to right away divide your space into two halves. So try to sketch a neat line right down the middle. And label one half of it. We're going to call this one option 1. Write small because we're going to use all of this space. And this one option 2 on this side. This is a 2-part question. Yes? So right now we have, he's saying he thinks right away option 2 is going to be better because you're compounding more, right? Yeah, he's saying compounded monthly, that's 12 times a year. Here, option 1 is what? 2 times a year. But are the interest rates the same? No. So this would be interesting to find out what happens. Let's come back to that at the end and see what happens with that. For option 1, what information am I going to pull out? What 3 variables do I need to build my model? P, R, N. What's P? 8,000. What's R? 7%, but as a decimal, 0.07. So careful. If you said 0.7, what are you saying? That's 70%. So I have a lot of people who are verbally helping me out right now. That's great. I need to see you writing this with me at the same time. So don't just contribute your answers. Make sure you follow with the notes. N is, careful, the first option, semi-annually, N is 2. What's our first step? Build the model. So A of T equals, in general form, P times 1 plus. Right here, David, semi-annually. Good question. So let's start building it. That'll be A of T equals 8,000 times 1 plus. Good, keep going. Yes. Yep. Raised to the 2t. In someone else, can I have what's inside parentheses? What is 1 plus 0.07 divided by 2? I heard you say it. I just need to hear it a little louder. 1.035 to the 2t. Oh, hold on. So that was the bell. I will finish. Sorry, let me let the bell go by. I am going to fully finish option 1 and option 2 and do this question as part of the notes. The homework is, this says, change this to a 9, please. That's a typo. There are 2 questions. So this is our homework for this weekend. In this video, I will finish the notes to support the homework. Any questions, please send me a remind. I'm going to pause this for a second and check for calculators. Come see me before you go. Great job today. Make sure you jump to this part of the video to finish your notes, right? I'll pause and I'll be right back to finish the notes in a second.
The homework.
Okay, I'm back to help finish these last couple of examples in the notes to get everybody all set for the homework. So we left off on building the model. I'm going to put it in a box. And now we're going to say, well, I'm asked for how much after 6 years. So that's my input. So I'm going to plug in A of 6 equals 8,000 times 1.035 to the 2 times 6. So I will just make a quick note that that means 12 is my exponent. Plugging that into my calculator, let's see what you get. So 8,000, open parenthesis, 1.035, close it, caret 12. And we get $12,088.55. For option 2, it says the second page, 6.85% compounded monthly. And just to reiterate, a student brought up that they think option 2 is going to be definitely better because we're compounding more. Compounding monthly, is 12 compared to 2. But we do have a different interest rate, so let's see how that's going to affect things. As always, let's build our model first. A of t equals p times 1 plus r divided by n to the nt. That'll be 8,000 times 1 plus 0.07 divided by 2 raised to 12. Careful with that. 12 raised to the 12t. N is now 12. In your calculators, work on getting what's inside parentheses. We should get 1.00571 raised to the 12t. Again, calculating A of 6, that'll be 8,000. That's supposed to be a 6. 8,000 times 1.00571 raised to the 12 times 6. 12 times 6 is 72, so that'll be my exponent. Plugging that into the calculator, we get, give you a second to get that. $12,053.95. Interesting result. So yes, we're compounding more. Here it's 12 times, here it's only 2, but this being the interest rate being a little less causes this one to get us more money. So we really should choose option 1. Interesting result. The last one in the notes is when you were born, number 3, when you were born, your parents started a savings account. So you would have a down payment on a car when you turn 16. They deposited $2,500 into an account with an interest rate of 4.25%. How much money will you have if it was compounded semi-annually? So pretending like this isn't a mixed practice, as soon as I see the word compounded, right away, that tells me in my brain I've got compound interest going on. So T will be time in years. A of T will be amount. of money. And we need three variables. What are they? Our three variables are P, R, and N. My principal amount deposited is $2,500. The rate is 4.25%. As a decimal, that's 0.0425. And semi-annually tells me that N will be 2. With that information, I'm ready to build my model. So this will be our 7th or 8th time writing the model. Hopefully we're feeling more comfortable as we write it over and over. A of t equals P times 1 plus R divided by N raised to the NT. That becomes 2,500 times 1 plus 0.0425 divided by 2 to the 2t. Use your calculator to get what the number will be for B inside my parentheses. Remember, A times B. So doing 1 plus 0.0425 divided by 2 in your calculator gets you 1.02125 raised to the 2t, and I put it in a box. That way you're saying, this is my model, I'm done building the model, and now we can use it. So the question, or the hint says, to know how many years for T, how many years have passed since your parents invested the money? Well, they started investing when you were born, and you just turned 16. So 16 years. So let's figure out A of 16. Let's see how much money you have in the bank for this car now, thanks to your parents' investment. So A of 16 equals 2,500 times 1.02125. Raised to the 2 times 16. Purely a calculator exercise at this point. 2 times 16 is 32. So that's 2,500 times, oh, well, I don't have to rewrite this. Just tell me what you get in the calculator. What do you get? $4,899. It's a little messy. $4,899.66. Check that out. So by depositing this much, how much did they put in the bank? Over 16 years, their $2,500 almost doubled. And that's now what's in the bank for your car. How awesome is that? All right, that wraps up the notes for today. The homework is the very next page. Send me any questions on Remind. Great job today on compound interest.